Hi viewers, this is Mrs. R. PADMAPRIYA from St.Joseph College of Arts and Science, Cuddalore, working as an assistant professor in PG and Research Department of Mathematics. Today we are going to discuss about operation research in the transportation problems. A small introduction to the transportation problem. Transportation problem is a special kind of LPP in which objective is to transport various quantities of a single homogeneous commodity to different destination in such a way that the total transportation cost is minimized. In that transportation problem, we are having various methods. One of the method is northwest corner method, that is NWCM. Let us first see the working rule for the northwest corner method. Construct an empty M cross N matrix completed with rows and columns. Indicate the row totals and column totals at the end. It should be balanced. Then only it is called a balanced transportation problem. Starting with 1,1 cell at the northwest corner of the matrix, allocate maximum possible quantity, keeping in view that allocation can either be more than the quantity required by the respective warehouse nor more than the quantity available at each supply center. Adjust the supply and demand numbers in the respective rows and column allocations. If the supply for the first row is exhausted, then move down to the first cell in the second row and first column and go to step 4. If the demand for first column is satisfied, then move to the next cell in the second column and first row and go to step 4. If for any cell supply equals demand, then the next allocation can be made in cell either in the next row or column. Continue the procedure until the total available quantity is fully allocated to the cells as required. Okay, let us see one problem depending upon the northwest corner rule. Developing and here we are going to find only the initial basic feasible solution, not the optimal solution. So let us start with the 1,1, that is the first row, first column. The given question is like this. Here the factory capacity and the warehouse requirement should be equal. If the factory capacity is 100, 300 and 300, and we will be adding, we are getting 700. The warehouse requirement is 300 plus 200 plus 200. So the total is 700. Let us choose the first cell 1,1. See the warehouse and capacity. You are having 300 and 100. See here. So you allocate 100. Strike out 300 and write the balance as 200. So strike out that entire row. So the next cell we are going to allocate is this cell 2,1. Okay, for that the next cell is 2,1. Assign 200 units. In this we are having 200. This side factory capacity we are having 300. So allocate 200. So strike out that 200 fully. Strike out the 200 fully. And the balance is 100. Here you are having 100. So strike out that entire column. So the next allocation we are going to the cell, second row, second column, this cell. Okay, assign 200 units from E to A. This means A's demand, E has 100 units remaining. So we move to the right to the next column of the second row. Okay, here see this. In this we are having here 100 units we are having. In this we are having 100 units, here 200 units. So allocate 100 units, strike out 200 and put 100 the balance. So strike out that entire row. Next we are going to allocate in the cell, third row, second column, this one. So assign 100 units from E to B. The E supply has been exhausted, but B is still 100 units short. We move down vertically to the next row in the B column. Okay. See this? See this? Assign 100 units. Now assign 100 units. Here we are having, see this? Here we are having only 100. So assign 100 units. So strike out this. When 100 units is assigned, we are getting the balance is 200. So the entire column is removed. The next cell is 3 cross 3. This cell we have to allocate. Assign 100 units from F to B. This fulfill B's demand and F still has 200 units available. Move to the last cell. The last cell in the factory capacity and warehouse requirement, you should have the equal number of requirements availability. So that is the 200 units. So assign 200 units from 4 Lauderdale to Leverland. This exhaust 4 Lauderdale's supply and Leverland's demand. The initial shipment schedule is now complete. We can easily compute the cost of this shipping assignment. So the route from to, write the from to unit shipped, that is what are the allocations we are given, 100, 200, 100, 100, 200 per units. Per units is nothing but the question given in the each cell. So multiply the unit shipped with the per unit cost. So the route is from, first route is from A to D. The unit shipped is 100 and per unit cost is 5. So 100 into 5, 500. Next the route is E to A. Unit shipped is 200. Per unit cost is 8. 200 into 8 is 1600. The next route is from E to B. Unit shipped is 100. So unit per unit cost is 4. So 100 into 4 is 400. The next route is F to B. Unit shipped is 100. Per unit cost is 7. 100 into 7, 700. The next route is F to C. Unit shipped is 200. Per unit cost is 5. So 200 into 5 is 1000. And we'll adding 500, 1000, 600 plus 400 plus 700 plus 1000. The answer is 4200. So this solution is a feasible solution, but we need to check to see if it is optimal or not. So this is the way of finding. Northwest corner rule is one of the way to find the basic feasible solution. Using this, we can also find the optimal solution. Thank you for watching.